Hello everyone, once again you're welcome to my channel. Perhaps if we have been following our previous exercise on lift and on our aircraft calculation, today we are asked to calculate the distance between aircraft nose and the point at which lift force is exerted upon, given that the coefficient of moment of lift force about the aircraft nose is given to be minus 1.7, that is negative 1.7. That is, we should calculate the distance between the aircraft nose and the point at which the lift force is exerted upon the aircraft. Perhaps if we have been following our previous exercise, we were given our aircraft wing chord, the wing chord of the aircraft C, which equals S over B. So C equals S over B. C means chord, wing chord, S means the wing area, and the B means the wing span. And we were given that our speed area, our wing area, which is 130 meters squared, over the wing span, which equals 40, which gives us 3.25. Therefore, we're given our coefficient of moment of the nose of the aircraft, which is negative 1.7. Our coefficient of lift, which we have calculated before, is given to be 0.29. So therefore, the formula for coefficient of moment, which equals to moment, equals half rho SV squared C. Our rho means the density on the sea level, our S means the wing area, our V means the speed, our C means the chord. So therefore, that's equation 1. Now, don't let us forget that moment equals negative LS, that is the multiplication of the distance to the load. So therefore, that gives us equation 2. From there, we have our coefficient of moment, which equals negative Lx over half rho SV squared C. From there, we can bring out our x over c outside from the bracket. Then we'll resolve to have negative L over half rho SV squared. Knowing fully well that coefficient of moment formula equals load over half rho SV squared, which gives us equation 3. So therefore, knowing fully well that this C, or coefficient of lift, we have it here, then we can slot it in and substitute to our previous equation to have our coefficient of moment equals negative CL multiplied by x over c. From there we have the distance between the nose and the where force of lift is being exerted, which equals x equals minus c over cm over cl. From there we have our x equals minus c over cm over cl. Our c, which equals the chord, 3.25 multiplied by our coefficient of moment, which is given as negative 1.7, over our calculated coefficient of lift, which is 0.29. So therefore, our x, which is the distance between the aircraft nose and the point at which the lift force exerted on the aircraft Boeing 747, equals 19.05 meters. Thank you.